Hi guys, welcome to TV Coder channels. For this video, I'm going to show you how I work on the data understanding part for the water quality data. Let's get started.
Welcome guys, thank you for watching my video. So for these videos, we're gonna start with understanding the data set of water quality. So first of all, the most important thing is where we're gonna download the data set. So I'm gonna open up a Google Chrome, then I'm gonna go to kaggle, and then I'm gonna search for the data sets, and I'm gonna just type for water quality, and this is the dataset that we're gonna work on it for this particular series of videos. And yeah, first of all, I would always like to actually create a particular folders for my particular projects or any data science projects or any coding projects, right? So of course I'm gonna name it as a water quality, and then yep, I'm just gonna go with download by clicking the download buttons and search for the folder, and yes, I'm just gonna download it. And once it's completed downloading, then I'm just gonna come to this folder and extract the data sets. You just delete the .zip file, and then I'm just gonna cut this out and paste it in this particular folder, and I'm just gonna delete the archive. Okay, so let's open up the data sets in Excel form. Yep, we can see that for this particular data set, we have around 10 features, right? So the last one will be the portability, will be the target features, and the other 9 will be the feature that indicate whether the water quality is good for human to drink or not. Right? So of course, our machine learning objective also is try to train based on these particular features in order to predict whether the quality is safe for human to drink or not. And yep, let's have a look on how many data points that they have. Is around 3,276. Yep, so they have around 9 features and 3,276 columns each. And of course, for this data set, we can observe with our bare eyes there are some missing value here, which we're gonna do some things on the preprocessing part in order to eliminate, or probably we're gonna fill it in with some values, right? Let's have a more detailed understanding about this particular data set first before we go into the data preprocessing part. So we will come to this particular website, and we can have a look. There's an explanation already ready in this particular data set for us, for all the data scientists to work on. So first of all, the pH value. Any values that less than 6.5 will be too acidic, and anything above 8.5 will be more to alkaline. So the safe range is actually put based on 6.5 to 8.5, which is we can for the strategy that how can we actually categorize it if we wanted to, is actually put any values that is less than 6.5 will be as class 1, then any values between 6.5 to 8.5 will be 1, and any value above 8.5 will be 2. So we can split it into 3 particular categories, or we just leave it as what it gives to us. So yep, so we can actually categorize it by this type of strategy. And for the next one will be the hardness level, is indicate how many calcium and magnesium salt is inside this particular water source, and it will cause the hardness level into increasing or decreasing. So yeah, probably we can, because there is not much of explanation here regarding the safe level or the hardness level that indicate how hard is it, how soft is it. So probably we will want to Google about this. So we can check hardness in drinking water, right? So we can press in the first one and have a look on it. So yeah, there's an indication here. Anything below 75 milligrams will be considered soft, and from 76 to 150 milligrams will be moderate hard. Any amount between 151 to 300 milligram will be hard, and anything more than that will be very, very hard. Okay, so we can categorize this particular feature into 4 categories. So what we can do is anything below 75, that will be categorized as class 1. Anything, this one will be class 2, this one will be class 3, and this one will be class 4. So it's 0, 1, 2, 3. Okay, then for the next one will be the solids, or the TDS, total dissolved solids. Yeah, probably desired limit. So probably that we can actually try to strategize this as 2 categories. Anything within 500 milligram to 1000 milligram will be considered desirable. Yeah, we should put it as desirable. And any values that not fall between this range, we can put it as undesirable. Yeah, so it should be class 0 and class 1 for this particular TDS. And for the next one will be chloramines. So chlorine and chloramines are the major disinfectant that used in public water system. Okay, so chloramines are most commonly formed when ammonia is added to chlorine to treat drinking water. So chlorine level up to 4 milligrams per liter are considered safe. So yeah, this will be a binary categorized as well. Anything below 4 or equal to 4 milligrams will be considered as safe, and anything above 4 will be considered as unsafe. So yeah, for the next one will be the sulfate. So yeah, let's have a look on Google the sulfate level. Sulfate safe amount in the water. So yeah, to be safe, only use water with sulfate level lower than 500 milligrams per liter to make infant formula. So older children and adults may get used to high sulfate level after a few days. Yeah, we can categorize it in this way, but let's have a look on this particular feature first, whether is it makes sense. Okay, we can have a look. The sulfate level, the minimum sulfate level consists in this dataset is 1 to 9 in milligrams, and the maximum is around 481. So there's no points that we base on this particular so-called information to categorize it, because all the maximum level that occurs in this particular dataset is less than 500 milligrams. So it's always the safe amount. So we can ignore this particular feature, we don't do anything on it. Yep. And then we'll go next, conductivity. So so there's a description about this particular feature that says that pure water is not a good conductor of electric current rather than a good insulator. So meaning that pure water cannot conduct electricity, or is not a good conductor, but instead is a good insulator, right? So what we can do is any values of conductivity that is less or equal to 400 will be considered as safe, and then any values will more than that will be unsafe. So it's 0 and 1 as well. So for the next one will be organic carbon, is a measure of total amount of carbon in organic compound in pure water. So according to US EPA, let any value less than 2 milligram per liter as TOC in treated or drinking water. So any values less than 4 milligram in later in source water, which is used for treatment. So yeah, we can actually categorize this as any values that less than 4 milligram per liter as safe. Any values that more than that will be unsafe. So yeah, this is also a binary categorization. Okay, for the next one will be a trihalomethanus. DHM level up to 80 ppm is considered safe in drinking. So this is also a binarized categorization. So we can put any values that less than equal to 80 ppm will be considered as safe, and any value above that will be unsafe. So for the last feature will be turbidity. It's actually trying to measure how clear is the water. So the mean turbidity value obtained from Wando Janet campus is 0.98 NTU. It's lower than the WHO recommended value of 5.0. So I think we just gonna follow WHO recommendation. So we put any values less than 5 or less than or equal to 5, that NTU will be equal to safe, and any values that is more than that will be unsafe. It's also a binarized categorization. So the last one, which is the target, will be the portability, which is 1 means that it's safe and 0 is not safe. Okay, so yeah, we gotta plan our strategy based on this understanding, which we're gonna do one set of data set that is gonna based on our explanation and understanding of each feature just now to categorize it. For example, we gotta categorize this pH value into 0, 1, 2, which is acidic, normals, alkalis, and same for others features like hardness based on the explanation just now, whether be it a multi-categorization or just a binary categorization. Then we can have another data set as well to just don't do any categorization, just remain all the values here. And what we're gonna do next for both data set, we're gonna drop all the rows which have nouns values, and probably for some nouns columns, right, nouns features, if the nouns values are quite less, we're gonna fill in the remaining noun value by using the mean of the whole features. Right, so this is one of the strategy we can apply, and if the feature have one of the feature have quite a lot of missing value, we're just gonna drop the missing value in row base. So this is another things that we're gonna do in the data preprocessing. So for what we're gonna do next will be checks the data distributions for this particular portability class. So we can have a quick check on here. So if we just select one particular classes and we have a quick look on the total rows that we have, like for example, the class 0 is having 1,998 rows. But let's have a look on the class 1. So yeah, we can have a look. It only consists of 1,278, which is an imbalanced data set in distribution, right? So of course, the next strategy we're gonna do will be apply the oversampling technique, which the basic one will be the SMOT, synthetic minority oversampling technique, to fill up the class 1 match with the numbers of class 0 as well. So last but not least, what we're gonna do is for the both data set, we just gonna normalize each feature into a scale of 0 to 1, so that it easy up our process of training, and it will fasten the speed of our model training as well. So yeah, I think that is all the strategy I'm gonna do for the next video, which is the data preprocessing part. And until now, thanks for watching. See you in the next video. Bye bye.